And now we start looking at some of the theories of knowledge that we have today. And I've put two people, Francis Bacon and John Locke, who have actually organized some of this in a non-theistic manner. So they were, the reason why I put these two people up is because only their photos are available, not that they were the only ones to do it. See, I mean, that's a whole other thing, but I will not talk about it right now. So let's get down to the core of this idea. The fundamental idea is what is called a feedback loop. And I'll talk to you about this in a second. So their basic statement is that knowledge is not revealed from the gods, but it comes only through sensory experience, experimentation and evidence. That is their fundamental idea. And that knowledge is tentative and probabilistic, subject to continued revision and falsification. This continued revision is what we mean by feedback loop. So you look at your knowledge, you have some tentative idea, you have some probabilistic idea, and then you go back and fix it. And this falsification is the fact that you get new data and it turns out that what you thought you knew was wrong. And then you have to go and change what you knew. So that's the idea. By the way, this is not something that's new. You can go back to the Vaisheshika Sutra in the Indian philosophy system, and it says very clear that perception and inference are the only two reliable sources of knowledge. So perception is actually sensory experience and experimentation, and inference is actually reasoning. Okay, and the clearest statement of these things come from two Arabic scholars, Ibn Sina, who is also called Avicenna, and Ibn Tufail, and they made the following statement. It is now, I mean, of course, they didn't say this. I mean, we are now translating it as this. So it says, syllogistic method of reasoning in which observations lead to propositional statements. So you make propositions based on observations, then you add them all up, you compound them, and then you lead to abstract concepts. So there was a lot of discussion about how people acquire knowledge and so on and so forth. And then finally, out of all of this, we have now gradually evolved into something which is called the scientific method. Oh, before we go there, I want to talk to you about another aspect which is called scientific rationalism. And it talks about the logical structure of knowledge. So their criterion for truth is not sensory but intellectual and deductive. So it is not based on senses. So the core idea here is that there exists truths or axioms that are beyond sensory knowledge, and we use that actually quite a lot. You might be surprised that we actually agree to this, which are, for example, when I say momentum is conserved, right? And that's something that we assume as a truth in classical mechanics, or an axiom of classical mechanics. But if you look at it, that's actually something that's an abstraction from a few limited set of experiments. No limited set of experiments can ever prove that it is true, because there could always be one more experiment in which momentum is not conserved, right? All you can say is that based on these 10 experiments, I make an inductive leap of faith by saying that momentum will be conserved. And then I see whether the results of such assuming that kind of an axiom are reasonable. If they are not reasonable, I go back and change it. That's how it works. Okay, so this is called inductive reasoning. That is, it allows you to go beyond just a compilation of sensory perceptions. It allows us to extend this to something more than that. Okay, now we come, after all of this different kinds of things, we now come to what is called the scientific method. And I want to point out that this is not a theory of knowledge, but an agreed upon incremental approach to acquiring shareable, coherent, sorry about the spelling, I just realized, coherent, verifiable knowledge about reproducible aspects of the universe. Notice how special it is. It does not talk about all knowledge. It does not talk about cures or anything like that. It talks about how do you generate shareable, how do you acquire shareable, coherent. That means it has to be somehow consistent, verifiable knowledge about reproducible aspects of the universe. So what do I mean by that? By the way, it does not have a notion of whether something is true. It only has a notion of whether something can be falsifiable. That is, can you find a counterexample which will render it untrue? And then inductive reasoning tells us that, what a binary logic you could say. If we accept that, then we say that which is untrue must be true. That which is not untrue must be true. But that's a real problem. So we will be careful about that. Okay. So all we can say is that, hey, we have some current working hypothesis, and that up to now it seems to provide reasonable results, and that it has not yet been falsified to the extent that we will abandon it. It still is useful to us. And this scientific method is a synthesis of a lot of different approaches to knowledge. To just give you an example, first item is shareable. The phenomenon under question must be converted into some symbolic representation. Words, equations, pictures, graphs, some symbolic representation that can be communicated. So that's why a mystic experience which cannot be communicated to somebody is outside the purview of science. It doesn't mean it's false. It just means that's not part of what we can do with science. The second item that's very important is this idea of reproducibility. So you have to be able to say that if the conditions are the same, the phenomenon can be reproduced. So, for example, miracles are outside the purview of science because they are not reproducible by anybody. So it's not, if you ask me whether it's true or false, the answer is it's actually not something that we can decide by using science. Science does not talk about miracles. Science does not talk about mystic experiences, these kinds of things. Right? The last one is falsifiability. That is, if I make a particular proposition, at least one possible outcome of the phenomenon must be able to render the explanation as inadequate or false. If everything fits and there is nothing, if you say God did it, then from a scientific point of view, that's not something that's falsifiable, because anything is possible then. Right? Same way, for example, if you don't want to say think about God, think about the following thing. Individual events in a probabilistic explanation are outside the realm of science. The reason is because if you have a probabilistic description of something, every event is possible even though it will have very slight probability. But it's possible. So if a single event occurs, it cannot be falsified. You cannot say it is not possible, because in a probabilistic description, it's possible. It's not a likely, but that's a different thing. So actually, what probabilistic explanations talk about is either degree of belief, how strongly we believe something, or it talks about recurrence of events. If I do the same thing again and again, how often will it show up? But it's not really talking about whether a particular event is possible or not. Okay, so we are, you can see that there are some issues with this, but that's how the scientific method is set up. This is what it is. And how does it work? So it starts out with observations. That is, think of it as uncontrolled experiments, or things that we just happen to observe, and that requires serendipity, that is luck. It requires curiosity. It requires empathy, so that you are actually looking at these things. It requires engagement, so that you are not daydreaming, so to speak. And it requires mindfulness. So engagement and mindfulness are similar, so that you are actually observing what's happening. So that's one of the reasons why, if you want to be a good scientist, you have to cultivate curiosity, you have to have empathy, you have to have engagement, and you have to have mindfulness. Otherwise, you will not make any observations that are worth observing. You will miss it. Right? Observations lead to falsifiable hypothesis about what is the system that is being observed, and what are the inputs, and what are the output, and what is the relationship between these things. So this is a hypothesis about this is the system, this is what is causing, this is what is the effect, that kind of thing. In order to do this, you have to reflect upon what you have observed. You have to do some inductive thinking, that is, abstract things out from whatever you have observed, so that you can make some sensible hypothesis. You have to have knowledge about what else is out there, so that you can actually say, oh, so this is an example of that kind of thing. And then you have to be bold. and you have to have belief in order. If you don't believe in cause and effect, and if you think everything happens by accident, then there can be no hypothesis. Right? So there has to be a belief in order to make any hypothesis. Once you have made an hypothesis, the next step to this is now do controlled testing or controlled experiments, a controlled observation. Because your hypothesis tells you what is the cause and what is the effect. This is where the reproducibility aspect of this thing comes. Can I reproduce the phenomenon in a setting where things are controlled? So now we come to this thing. In order to do that, you have to have creativity so that you know how to design the experiment. You have to have craftsmanship. Those of you who have built any kind of experiment know how important that is. You have to have mindfulness and detail orientation, because you have to control for a lot of features, and this is a very hard thing. And you have to have infinite patience, and you have to have the ability to design things. Okay, once you have done that, then the next step comes reasoning from the deductive reasoning and refinement of your hypothesis from the experiments. So now you have to switch from belief, remember we talked about belief when you're doing hypothesis, to skepticism. So you can see that you need both. You cannot just be a true believer all the time. If you're a scientist, you have to have both belief and skeptics. The skepticism, and then you have to be meticulously organized so that you can show that the experiments can be repeated and so on. And you have to have analytical thinking capabilities so that you can actually reason, deductive reasoning from experiments. And then that may lead to new observations based on what you reasoned. And then you say, oh, so this might mean that I should be able to see that. And then you see whether you can see that. This is how scientific method works. This sequence. Okay. And you can see you need a variety of different kinds of thinking to do this.